boys and girls, I'm going to show you how the jet stream impacts our weather. And we're going to take a little bit of notes. So I want you to be able to draw and also explain and understand how the jet stream works. All right, so the first thing you need to do is you need to remember that currents are basically tunnels of water or air that move more swiftly than the air around them. And the air or water around them. All right. We have talked about the Gulf Stream, and so you guys are aware of the fact that there is a water current that we have to know in fifth grade science. We know that the Gulf Stream is the current that starts in the Gulf of Mexico, right? And we know that the Gulf Stream is very warm, and we know that it travels around the coast of Florida. We know that it comes by Georgia and South Carolina and then North Carolina, and then it crosses over and comes to Europe, where it impacts the United Kingdom, which has England and Scotland and part of Ireland in it, and also the actual country of Ireland. So these island countries in the Atlantic off of the European coast, which is also part of Europe, they get much warmer than they would normally be. Remember that this latitude is about 60 degrees north, which is equivalent to like Canada, right? And also over here in Russia, where it's really, really cold, where like Siberian Huskies are from, right? So it should be very, very, very cold in the UK and in Ireland. But because of the Gulf Stream current, which is a warm current, right? Then we know that the climate there in the winter is about the same as Charlotte, just rainier. It's about the same level of cold as Charlotte. And in the summer, they stay cooler too, though. And that's because they're on the ocean. Remember, warmer winters, cooler summers, less change in temperature. So about here would be like NC, and then South Carolina, and then Georgia, and then Florida. So now, it's really important now to know that there are currents both in the water and in the air. And we focused on the Gulf Stream, the water current that we have to know for our fifth grade science. But we also need to talk about the one major air current that we have to know for fifth grade science and weather, right? So the current, the Gulf Stream, is more about impacting the climate. Though there are ways that it can impact the weather too, but I tend to think of it as like impacting the climate of a place more than the weather, although both can be true. And remember that climate is when you study the weather for a really, really, really long time anyway. So now on the bottom part of your paper, if you're doing this with me, then what I want you to do is I want you to make a section for the jet stream. Now, just the fact that it says jet, the jet stream helps us to remember that the jet stream is an air current. All right, it's an air current that flows across the United States. So what you need to do here in your notes is you need to draw just the best you can an outline of the United States. You know, even when I do it, mine's going to be just like a blob. I'm going to come down here and draw Texas. Then I'm going to draw the Gulf of Mexico and then come down and make a peninsula for Florida. Then I'll come over here and come out for North Carolina and then back up here for Maine. So you can see it's pretty blobby. But if you can make something that even looks remotely like that, then you're cool because that's really all you need. All right, so now around the entire world, not just across North America where we live, right? But around the entire world at our mid latitude level, right? Remember, we live in the mid latitude where we have 4 seasons. We have 4 seasons, right? The whole United States is in that mid latitude zone. There is an air current that is pretty high in the atmosphere, and it blows across the United States, and sometimes it's farther north, like up in Canada, right? And so what you do is you just draw a tunnel, but you need to remember, like you're kind of drawing a path, but remember that it goes around the whole world, right? Always blowing from west to east. All right. So this tunnel has a really important job when it comes to weather and climate, but in my head, I think of it mostly as weather. It acts as like a wall almost. So here we're going to label this the jet stream. And remember, this is in the air, jets fly in the air. It forms a barrier or a boundary. You might see the word boundary. And maybe down here you should write the jet stream forms a boundary between cold polar air and warmer air. So that's kind of the main gist here. The jet stream forms a boundary between cold polar air and warm air below it. So what I want you to do is with your blue colored pencil, I want you to shade in with blue to represent cool air above the jet stream. So basically it blocks the polar air from up at the North Pole and keeps the North Pole air that's so cold on the north side of the jet stream. In the summertime, the jet stream moves really far north and takes the cold air close to the North Pole. But during the winter, the jet stream dips down, and sometimes other things can make it dip down, like El Nino and La Nina. But for the moment, right here, with the amount of information that we have, we're going to be thinking about the fact that the jet stream dips down, and when it dips down, it brings cold air with it. So like here, let's mark North Carolina, even though this is probably a little inaccurate. Let's make like North Carolina right about here. One of the main things you need to know is that when the jet stream comes down below North Carolina, it brings cold air with it. And North Carolina's temperatures are pretty cold. All right. Now, underneath the jet stream is always much warmer air because the jet stream acts as a boundary for warm and cold air. Now, as we're coloring in the warmer air to the south of the jet stream, and by the way, this is the polar jet. There are other jets in the world, but for 5th grade science, we focus mostly on the polar jet. All right. And so I want you to be thinking about this fact. If the jet stream forms a boundary, see, a boundary is like a line, a dividing line. If the jet stream forms a boundary between cold and warm air, and if then every time you make a cloud, remember warm plus cool equals cool condensation cloud? Remember that? So if the whole way the jet stream is flowing, there's cold air north of it, bumping up against warm air south of the jet stream, what do you think happens under the jet stream a lot? See, like right here, warm will hit cold, 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 warm will hit cold. If warm is hitting cold everywhere that the jet stream is, don't you think perhaps the jet stream would make a lot of clouds? And then further, don't you think that maybe underneath the jet stream, there might be lots of rain? If you're agreeing with me, then what I would maybe do is just with your regular pencil, go in and color the jet stream a light pale gray color. Just show how where the cold air and the warm air meet, you have cool condensation cloud. And wherever the jet stream is sitting over top of you, you have more rain. Right now, North Carolina might not have so much rain based on this map because the jet stream is to the south of us in this map, but we would definitely have some cold air. So just something to consider is basically the jet stream is a giant front where warm plus cold equals cool condensation cloud. Right, so the main thing to know is that north of the jet stream is always cold air. Here, let me get my pen. Cold air north of jet stream. And warm air south of jet stream. Clouds and rain wherever the jet stream is, because cold air is hitting warm air. And for the moment, that's a pretty good amount of notes and information for you about the jet stream. Let's go ahead and put north and south. All right, and then we'll practice some questions about the jet stream so you can apply this information.